Hello friends, this is the third video on the merchant circle diagram, and this is also the last video on this topic. And in this topic I will discuss about the various formulas which can be easily calculated using the technique or way or method which I am using here. And after watching this video, you don't have to remember all the formulas. Anytime you can calculate by yourself during the exam time, and this is very easy. You just need 2 or 3 times practice to calculate the formulas which are related to the merchant circle, and very important formulas these are. So to calculate, as in the last video I have discussed about the various forces, and all these formulas are in the term of those forces only, and that same diagram will be used to calculate the forces. So quickly I am drawing here the merchant circle diagram, or the relation between various forces. As you know, this is the cutting force Fc, and this is the thrust force Ft, Fc and Ft. This is the resultant R, and this is the shear force. This is shear force Fs, and this is normal to the shear force Fn, and this is a vertical line. This is the friction force, and this is normal to friction force. Next, friction force F and normal to friction force N. This is the friction angle beta. This is the rake angle alpha, and this is the shear angle phi. This is 90 degree. This is also 90 degree, and this is 90 degree. First, I want to explain one thing, that most of the people are thinking that why this is called circle, merchant circle. What is the need of to draw the circle? There is a theory, as we know, that suppose this is a right angle triangle, and this is the right angle. If we are drawing many number of right angles triangle, and all these points of the triangle which are making the right angle will come on the periphery of the circle. This is a theory. That's why this is called circle, because these all points will come on the periphery of the circle. This R is the diameter of the circle. That's why this is called circle. Now these all are forces, and suppose this triangle, this is making an angle 90 degree. Similarly, here is 90 degree. These are equal and opposite angles, so these are same. So third angle will also be same. Here it is phi, so this will also be phi. Similarly, this is alpha. This will be, I am extending this line here. This angle will also be 90 minus alpha. So this is 90 minus alpha. This is 90 degree right angle. So this will also be alpha. Okay, because the total is 190. Total will be 190. So this will be alpha. So now we will calculate the various formulas related to. We will use to calculate the value of Fc and Ft, cutting force and thrust force. We will use the shear force and normal to the shear force, Fs and Fn, and then we will find the value of Fs and Fn in term of Fc and Ft. Similarly, then we will find the value of FC and FT in term of F and N. And opposite to that, we will also find the value of F and N in term of FC and FT. Okay. So let's complete this rectangle. Let's complete this rectangle. Now this is FC. So this length is equal to FC. This is FC. So now FC is equal to this plus this. This plus this. Now I will writing here the formula for FC. FC is equal to this plus this. To find the value of this one, this is equal to this. This length is equal to this one. So and it is making this triangle FN. So I will first find the value of FC in term of FN. So first I will write here FC equal to this length is how much is this triangle. This is the like perpendicular part of this triangle, this one. Fn sin alpha. This is Fn sin alpha. Fn sin alpha. Sorry, alpha. No, it is not alpha, it is phi. This angle is phi, na? So it is phi. Fn sin phi. This length is Fn sin phi. Fn sin phi. Because this length is equal to this length and we have to find this length. So we are considering this triangle. So it will give this length is Fn sin phi and this is equal to Fn cos phi. Similarly, this length is equal to this length and this line is shear force Fs line. So this length from this point to this point, this is Fs cos phi plus Fs cos phi. Now similarly we will find for the Ft, thrust force. Ft is equal to this minus this upper part. This minus this is equal to Ft. This is Ft. Ft is equal to this total is the Fn cos phi. Fn cos phi minus this one upper part. This is equal to Fs sin phi. Fs sin phi. Now here we will use one shortcut method to calculate the value of Fn and Fs. Now multiply this first equation by sin phi and the second one by cos phi. If we multiply this first one by sin phi, then this will become Fn sin square phi. And multiply this by cos phi, then this will become Fn cos square phi. Means F, and if we add this and this equation, then Fn sin square phi plus Fn cos square phi will become Fn. So this by multiplying this equation by sin phi and multiplying this by cos phi, and after adding them, this will give the value in term of Fn, and this will Fs sin phi cos phi. This is Fs sin phi cos phi. This will cancel each other. So value will come in term of Fc sin phi plus Ft cos phi. Similarly, now we will multiply upper one with cos phi and multiply with this second one with sin phi, and now this time we will subtract both. So when we subtract, this will become Fs cos square phi, Fs sin square phi, and when we subtract, then this will become Fs cos square phi plus, because there is negative sign, so Fs cos square phi plus Fs sin square phi. This will equal to Fs. So this will give the value in term of Fs. multiply this equation by cos phi, multiply this equation by sin phi, and then subtract. So this will give the value in term of fs fc cos phi minus ft sin phi. So we have four formulas here, fc, ft, fn, fs. Now we will calculate the value of fc and ft in term of friction angle f and normal to friction angle n. Then we will calculate the value in term of value of f and n in term of fc and ft. First consider this fc similar to this length is same, so fc is equal to this one is equal to fc, and this is this plus this length plus this length. So this length is f, this is consider this triangle, this one, this and this, f sin alpha, because this is perpendicular and this is hypotenuse, so this will give the value f sin alpha in term of f sin alpha. So this fc equal to this plus this, okay, fc equal to f sin alpha plus this will give the value in term of n cos alpha. Similarly, for ft we will find the value in term of for ft is equal to, ft is this and this length is ft, and so we can calculate this total length minus this length, this will give the value of ft. Total length is equal to, in term of f cos alpha, this length is f cos alpha, ft equal to f cos alpha minus this one, second part, this length, this is n sin alpha minus n sin alpha. Now multiply first one by sin alpha and second one by cos alpha and add. This will give the value in term of f equal to fc sin alpha plus ft cos alpha. Now again multiply first one by cos alpha, second one by sin alpha, and subtract from this, subtract ft, this equation from this equation. So and this will give the value in term of n equal to fc cos alpha minus ft sin alpha. So we have 1 2 3 4 5 6 7 8. So this, now using this technique you don't have to remember all the time these formula. If you continuously you practice this method 2 or 3 times, then definitely you are able to calculate all these equation or formulas by any time during the exam. This will not take the time. If you do your practice more and more time, then this will take the less and less time to solve these equations or these formulas. So these are the value of all these formulas, and now as I discussed in the last video, this is the value of alpha and this is the 90 minus beta. 90 minus beta. So this equation is, this total is 90. So this angle is equal to, suppose this is theta, this is equal to 90 equal to theta plus 90 minus beta plus alpha, and this is equal to 90 and 90 cancel, beta equal to theta plus alpha, or we can find the value in term of theta, theta equal to beta minus alpha. So this angle value of beta is theta is beta minus alpha. So you can find the value of resultant R in term of, if you know this complete angle phi plus beta minus alpha, if you know this complete angle, then you can find the value of R using this triangle Fs and Fn, R, this triangle. You can find the value of resultant R in term of Fs and Fn, because R is equal to Fs square plus Fn square and root of the Fs square plus Fn square. Similarly, you can find the value of in term of Fc and Ft using Pythagoras theorem, and similarly you can also find the value of F and N in term of value of resultant R in term of F and N, because you have the angle value of angle beta. So if as we know mu equal to F by N, so you can put here the value of F, this one divided by this one, this will give the result value of mu. This method is used when you are not drawing the merchant circle diagram, but you are calculating by using the various formulas only, value the various forces, you are calculating the value by using equations only. If you are capable to draw this circle and you have some initial values, then you don't have to need to draw this, calculate this, or drive these equations. Okay, so hence we can find the value of resultant R, or coefficient of friction, or all these forces involved in this merchant circle diagram or cutting operation. One more thing is that this is the shear force, and this Fn, normal to shear force, this is also called the backing up force, backup or backing up force. So remember this sometimes asked in competitive exams, what is the backing up force, and that's, I think that's all. That's enough for this merchant circle diagram. So in 3 videos I have covered this merchant circle diagram topic, and most of the questions that are related to merchant circle diagram that generally comes in competitive exams, I have covered in these videos. And if there is some more question, or I think it will be better if student will discuss the various questions that are based on merchant circle diagram. If they will discuss in the comment box, then it will be very good for me also, because I will learn from them. Okay, so thank you very much.